Hello, I'm Aiden Wire, and today I will be taking an in-depth look at SQL injection. The purpose of this presentation is to give you, the audience, an insight into what SQL injection is and the threat it poses, while also looking at what SQL injection targets and how we can detect website vulnerabilities. Finally, in addition to an SQL injection definition and some detection techniques, we will also explore prevention measures developers can take to ensure their applications are better protected against this type of attack. These methods will look at client and server-side defensive coding, as well as mitigating SQL injection risks using regular expressions and other techniques. But before we can detect and prevent SQL injection, we must first understand this type of attack and the motives or goals of the attackers. So what is SQL injection? SQL injection is a type of attack which targets web-based applications which rely on databases. As websites have evolved from static HTML pages to dynamic websites with multitudes of input fields which interact with background databases, the threat of SQL injection has drastically grown. According to the researchers at Bina Nusantara University in Jakarta, Indonesia, SQL injection is the most common attack which targets web applications and can result in, quote, damage or loss of data, leaking the data to unauthorized parties, use of unauthorized access rights, loss of accessibility by the authorities, and web piracy or fraud by hijackers. SQL injection is often a very easy vulnerability for unskilled attackers to exploit and can allow a skilled attacker to take overall control of a website. The scope and severity of this attack are why it's consistently listed in OWASP's top 10 list for web-based application exploitations. Next, let's take a look at the different types of SQL injection attacks and examples of each. Jai Puneet Singh of Concordia University in Montreal, Quebec, classifies the types of attacks into two subcategories: classical and advanced SQL injection, with the latter posing a greater risk as these attacks can often overcome many techniques used to mitigate classic SQL injection attacks. Classic attacks include piggybacked queries. This type of SQL injection attack is characterized by the attacker appending a malicious query to the end of a legitimate input. As seen in this example below, an attacker forces the application to execute multiple queries, the latter of which deletes the rows where a customer's name is equal to Albert. Piggyback queries can be used to retrieve data which an attacker does not have authorization to view or edit. Additionally, an attacker executing a piggybacked query can deny user service by altering or deleting data. The next classical attack we'll look at is the stored procedure attack. While stored procedures are often used as a defense against attacks like the aforementioned piggybacked query, stored procedures do not guarantee an attacker cannot execute an injection attack. The below procedure is vulnerable as an attacker could enter any username followed by a single quote and two dashes. This effectively comments out the and password equals password parameter portion of the query. Another classical attack is the union query. This attack uses the union operator to append a malicious query to a valid input. This attack is used to circumnavigate defensive coding techniques which prevent piggybacked queries by checking for semicolons in input strings. Below is an example of a union query attack. We can see the first legitimate statement is unioned with a malicious statement which returns a user's credit card information. Our last type of classical attack is alternate encoding. Like the union query, this attack is a response to SQL prevention techniques which check for specific characters and strings. The attacker utilizes, quote, hexadecimal, Unicode, octal, and ASCII code in this query. Attackers use the char function with one of the previously mentioned encoded strings as a parameter to bypass security checks which prevent piggybacked or union queries. Now we will look at the modern and advanced types of SQL injection attacks. These attacks pose a greater risk to website applications as they cannot be prevented using the same techniques which defend against the classical attacks. These attacks are also used to infer information about the database and include the blind SQL injection attack. This attack uses true or false statements to help a user determine the characteristics of a database when display of SQL errors is disabled by the web application developers. This attack is similar to standard SQL injection, but the way the attacker retrieves the data based on whether the response returns true or false allows the attacker to begin to determine what extent the web application is vulnerable to injection. And the last type of attack we will look at today is the compound SQL injection attack. This attack involves utilizing an SQL injection attack alongside another type of web-based attack. Types of compound SQL injection attacks include SQLI and DDoS attacks, SQLI and DNS hijacking, SQLI and cross-site scripting attacks, SQLI using cross-domain policies of rich internet application, and finally, SQLI and insufficient authentication. As you can see, SQL injection attacks exist in many forms, but the underlying principle of using database queries to exploit, retrieve, or deny service to data is consistent through each type of attack. Now that we understand what SQL injection attacks are and how they're executed, we can now begin to look at ways to detect if an application is vulnerable to these types of attacks. There are many types of techniques and software a developer can use to determine if their web application is vulnerable to SQL injection attacks. But for the sake of time, we'll look at two detection techniques. The first being an SQL injection detection algorithm based on support vector machine, and the second being a traffic-based framework for detection called Diava. The first SQLI detection technology we will look at was developed by the researchers at Chongqing University of Posts and Telecommunication in Chongqing, China. The creators of this technology found that most SQLI detection was done through a system of case matching, and they theorized that a machine learning algorithm would be successful in detecting unknown SQL injection attacks. The researchers found their method was more successful at detecting SQL injection attacks than traditional methods, but noted some problems with their algorithm. The first of which is the requirement for a large data set of known SQL injection attacks in order for the algorithm to be effective. Additionally, the researchers use word2vec, which saves text vectors directly into memory. Because of these two factors, the resources required by the SVM-based detection algorithm is less than ideal. The other detection technology we will look at is Diava, and a diagram of its framework developed by its creators can be seen here. Diava works by passing the request traffic through multiple regular expression levels, the first of which can, quote, filter out network traffic without containing suspected SQLIAs. The second regex layer is used to, quote, identify successful SQLIAs. And the third and final layer is used to, quote, extract the leaked sensitive data in the form of either plain text or ciphertext. In other words, the regex layers take all the traffic, filters out the non-malicious requests, then filters out the unsuccessful SQLI attacks, and finally filters out the leaked data. From there, if the data is encrypted, Diava converts it into plain text using a dictionary attack. Diava is an excellent tool to scan the traffic of a web application to determine not only the vulnerability of your website, but also analyze data that is being leaked in real time. Now that we have a greater understanding of what SQL injection is and how we can detect it, the final aspect to explore is prevention. Let's start by recalling the types of SQL injection attacks and the techniques used to prevent them. The first type of attack we examined was the piggybacked query. Prevention of this type of attack is relatively straightforward. If we refer to our example code, the attacker enters a string into the password field containing a legitimate input, followed by a single quote, a semicolon, and then a malicious query which deletes data from the table. To prevent this, a developer could parse the string for a semicolon, which denotes the end of a query, and if found, prevent the query from executing and return an error to the user. Ideally, this character checking should be done on the client and server side before the query execution. Our second example was SQL injection on a stored procedure. Similar to the piggybacked query prevention, a developer should implement a system of input checking which parses the inputted string to check for malicious character patterns such as the double dash or semicolon, amongst others. Additionally, the username and password variables should not be added to a string and then executed as an SQL query, as this allows the attacker to input a single quote to alter the query and add malicious aspects to it. Additionally, it is a good practice to not, quote, store the critical information on the stored procedures as it lacks the most important security features. Next, we will look at the remaining SQL injection attacks and discuss how to prevent them. If you remember, union, alternative encoding, and blind SQL injection attacks are a response to input checking techniques which prevent piggybacked queries and stored procedure attacks. However, while the other two attacks use defensive coding techniques to detect and prevent attacks, a good way to prevent union query, alternative encoding, and blind SQL injection is to utilize a tool like Amnesia or SQL Check. Amnesia combines both static analysis and runtime monitoring to prevent SQL injection attacks, but is ineffective against stored procedure attacks and only works on Java-based applications. So, developers should use each method according to the language and scope of the application. Additionally, these should be used alongside defensive coding techniques for optimal SQLI prevention. To conclude, SQL injection is one of the greatest threats to web-based applications. Successful SQL injection attacks can result in leaked data, distribution of malware, denial of service, and destruction of databases. Because of the plethora of information online, lack of proper web security, and ease of execution, SQL injection is often defined by OWASP as one of the biggest risks to web security. Hopefully, by the end of this presentation, you have a better understanding of these attacks, the technologies used to detect them, and the prevention techniques you as a developer can take to better protect your web application and your data. Thank you.